but we're going to do the sine wave, which we talked about a little bit yesterday. Is just a pure tone. It's just a single tone with no harmonics at all. So that's what we're going to listen to. So we're just hearing that one pitch. Oh, and then I'm going to put a tuner on here too. Okay, so we can see the frequency here on the analyzer. We can see the tuning of it. It's so low it's not even registering there. And then it's actually on the speakers right now, but it's 20 hertz, which these speakers can't really produce 20 hertz. So you need a bigger woofer and more power and stuff to do it. 28, you guys hear that? Okay. Okay, and we'll talk about, in a couple more labs, we'll talk about the Fletcher-Munson curve, which basically is our perceived loudness. So you'll notice I have to adjust the volume of the track as we move around, because it's harder for us to hear low frequency. It takes more volume to sound the same loudness.
I mean, I can still hear it.
Yeah. Okay, so that's 28 hertz, and actually that's showing up there as like an A. It's all mathematical too, so if you think of A440, you cut that in half, it's 220. Cut that in half, it's 110. Cut that in half, it's 55. Cut that in half, it's 22 and a half. No, 27 and a half. We're right there at 28. So you see how we're just a slightly sharp A? This is the lowest note on the piano, this A right here. When you play the note on the piano, it has all the harmonics too, so it's easier to hear. This is just that note. Okay, so 35, that's that slightly sharp C sharp. And that one, now the speakers are actually doing a better job at recreating it. Okay, so the speakers are imperfect. So you'll hear that, how we couldn't really produce the low stuff very well, and then as we get to the high stuff, it gets hard to do it too. It'll start getting loud, so I'll adjust this volume back down as we go up. So there's 43. This is actually like 39 hertz is the low frequency of the bass. Like 42, 41. So like 41 hertz, that's the low note on string bass or electric bass. Unless it's a 5-string, then it's a B, like close to where we started. So there you go, reference-wise, that's where we're at. And then we get up to 50, and then at 55, remember 55 is like an A, so I'm at 56, so it's a little sharp. When we get up to 60, 60 is a very important frequency for a couple of reasons. It is like an 808 bass, if you guys know what that is. So it's very hip-hop bass. It comes from an 808, Roland 808 drum machine in the 80s. It's just playing this sine wave, but just like popping it on and then turning it off sort of thing. So that's where this sound will be very familiar. And then 60 hertz is also where the kick drum usually sits, which is why the 808 gets used as a kick drum. And so it's where a lot of that thud happens from the low kick and stuff. And then it also is the frequency at which our AC power runs. Sometimes there'll be noise in an audio system that's AC hum, and it will sound like this, but it will have harmonics on it too. So it'll be buzzy, but it will have this kind of thing. So that's 60 hertz. It's between A sharp and B flat. I mean A sharp and B flat. It's between B flat and B natural is what it is. So a lot of times in hip hop production, they'll actually tune their 808s, so they actually hit like a note in the song, and often they'll tune it a little bit flat down to a B flat, so that they can be in E flat major or B, G minor or something like that, and it's in tune with the song. So we'll keep going up. Okay, there's 76. Notice how it's a lot quieter right now. 88, 92, 100, and then there's your A is actually 110, because like I said, it's all math. So A440 divided by 4 so there's 4 octaves below A440. So we'll go way higher than this. So there's 120. Okay, we start moving up, and now we're getting into more of the audible range. So there's 220 is the A. This is the A just below middle C, because the A above middle C is 440, right? And then like 260, it's like 261. There you go, there's middle C. 260, 300, 350. So that's the F sharp above middle C. And then of course, we get to A440. They will usually do like a triangle wave.
Oh.
There's a triangle wave. So it has some harmonics, and you'll learn about that in the other lab. But that's usually what the tuners will have, some harmonics. It's a little easier to hear. But that's just the straight single tone. So we'll keep going up. So once we get over 500, see that's the C above middle C, 520. Okay, now we're above the treble clef. Here's the top of the treble clef, the E, F, G. Okay, and when we get up to 1,000, just making you feel a little bit uncomfortable, that's my goal. Okay, so there's 1,000, and this is actually a very important one. I'll mute it for a second. So this is like test tones and stuff like that. They use 1 kilohertz all the time for it, and the reason for it is actually one of the big reasons is that it's the most sensitive part of our hearing range. So it's really easy for us to hear that. That's where a lot of the prominence of vocal speech is in that 1 kilohertz range. But that is like this, it's like 2 octaves above middle C, you know, so that's like this high C. And so this is where we get into harmonics, which you'll talk about with Josh, where a lot of what we hear are those harmonics being prominent to give us intelligibility of voices and stuff like that. It's not always the fundamental. We think about the fundamental when you're singing and when you're playing an instrument as the main thing you're hearing, but we just went through all the fundamentals basically, and there's so much more. And so all these other frequencies are going to play a big role in the timbre of the sounds. So, but yeah, lots of beeps and stuff on like little toys and electronics are going to be these. Okay, so the one kilohertz, and I'll do a screenshot.
Woohoo!
Okay, we'll keep going up higher. 1.4 kilohertz. There's 2 kilohertz. I'm going to turn this down a little bit, because this is all the really prominent frequencies of our hearing. 3 kilohertz. Okay, and it's still, we can hear an audible pitch. We can tell that there's a pitch there. That's a G sharp. But the tuner starts to not work because it's like too high for it. It's not supposed to tune frequencies that high, is the thing. There's 4 kilohertz, 5 kilohertz, and you notice we move through it faster. That has to do with those octaves, like I was kind of alluding to yesterday, and you'll see it here. If we zoom in, you can see we have an 8 hertz there, 16, 31, 62. These are all octaves. All these lines are octaves. But here, from 8,000 to 16,000 is the same octave distance. But there's like 8,000 frequencies between it instead of 16 or something, or 41. Okay? So anyways, as we keep going, you'll see that this jumps faster between those because it's kind of trying to travel as octaves. Okay. So there's 7,000 or 7 kilohertz. Okay, and once we get up to like 8, you can still kind of hear the actual pitch, right? But we're going to start getting where it almost sounds more like airiness or noise than actual pitch. Okay, so that's 9 kilohertz, 10 kilohertz, 11, 13. You still hear that nice and strong?
Yeah.
It's starting to roll off for me because I'm older and I've listened to way too much loud music, done too many live sound gigs. 14, 15 kilohertz. Have we still got that?
Yep.
Okay. 17.
Barely.
Off.
Barely.
on.
Oh yeah.
Okay.
Dang.
And then 18. Okay. Women actually have better high frequency hearing than men. And then
That one's a lot
we're going to get to the point where the speakers can't even do it anymore. Okay, but anyways, there you go. That's all the way through. Now we can just take it all the way back down.
What you, I guess this is the way to visualize what you're hearing. And this is what you call a sine wave. And this is a square wave. Wow. Mario. Actually tell, because of its shape, that it's different from that. And this is a triangle wave. Ta-da. Every sound everywhere has harmonics. Except the sine wave, because it's literally just one thing, one tone. That's it. We could show it through different instruments, like, say, a trombone. And you can see all the different harmonics that's taking place. It's obviously a C, but there's so much more happening than just that harmonically.
Thing on the bottom is like.
Yeah, it's going wild. A clarinet. Where it's kind of a more mellow instrument, but it still has those frequencies kind of as other wind instruments would, or brass instruments, but it's a much more mellow tone. So everything has its tone, timbre, harmonics in play all the time, always. But look at the wave and how, I guess, wavy it is. It's not square, it's not any of that, it's not really going crazy even. Or the flute maybe. The flute's a little different because the breath of the flute kind of gives it a big part of its character and timbre.
You'll be able to hear the echo a lot better. You'll be able to hear echoes off of metal or big cement better than like trees, because the trees will absorb the sound a lot more. Metal surfaces are the best that you hear the echo. And so like if we're hearing sound, or like if I hit this right here and we're listening that way, we won't hear much of an echo off of it just because there's not much over there besides trees. If we listen that way, you'll hear some away, but again, not much. It'll mostly be off this building. But if we walk as far that way and listen this way and hear it off of this building, you'll hear a good, you won't really hear the delay, but you'll be able to hear the delay. And so, if y'all want to come like over here, so I'm not like playing at you, try and listen for the delay, where you can kind of hear the echo, but it's not that prominent. Let's walk this way and do it again. The legs of the building.